there, this is Leslie Light. Today we're going to be talking about prototyping in EPICS 151. We're going to talk about why, how, when, and where. First of all, why? There are two purposes for prototyping. The first is internal processing. When you make a prototype, it forces you to make choices. How big is this thing? What will fit within that shape? How will it best interface with users and other components? It also helps you evaluate technical feasibility of your solution. Does it look like what you expected? Does it function as you expected? Do the users interact with it like you expected? When you prototype, you'll be confronted with unanticipated problems, and you will learn by building. Examples of this are like finding a problem in your circuitry. It's best to find a problem in your circuitry early rather than at the very, very end. Finally, learning to work with basic materials and learning to use the workshop gives you skills that you can use in subsequent coursework at Minds, as well as in your career and your whole life. Another purpose of prototyping is to gather feedback from others. Your prototype provides a tangible expression of your solution concept for user feedback. You'll find out which concepts do your users really prefer. You'll be able to see firsthand what their emotional response is to your concepts and solutions. And you'll also discover what additional questions need to be answered. You'll use this feedback to incorporate into your next iteration, next cycle. The more you do that, the closer you'll get to a really good solution. In EPICS, you'll produce both a rough prototype and a more refined prototype. The rough prototype will be due with your design proposal, and the refined prototype will be due with your final presentation. What's the difference between a rough and refined prototype? I'm glad you asked. Here are some photographs and examples of really rough and quick prototypes, kind of rough and quick prototypes, and more refined prototypes. Check out the time frames below. Really rough and quick prototypes can take somewhere between a half hour and a couple hours, whereas refined prototypes might take you up to 20 hours. Always double your estimate of how long it's going to take you to build a prototype. The right materials for the different roughness and refinement of prototypes can be seen on this slide. For really rough and quick ones, recyclables, other found objects, quick graphics, cardboard, those sort of things can be used. Whatever's on hand, you find and you build into your rough prototype. For the pretty rough and quick prototypes, you'll use more things like bought materials like cardboard, foam core, foam, maybe even aluminum. You can use either hand sketches or printed out graphics, but they don't have to look so neat. You can see from the pictures that there's still lots of gaps. They don't look real. For refined prototypes, use materials such as foam, wood, RenShape, maybe 3D printing, more on that later, plastic, metal, and you'll use high quality graphics instead of hand sketches. Let's look about where your rough prototype and your refined prototype will be due this semester. Your rough prototype is going to be due in the analysis stage, and you'll use it to get feedback from the end users. You'll use it to learn about your design as you make the prototype, and you'll present it along with your design proposal. The refined prototype will be due at the end of class with your final presentation of your solution. The intention of the rough prototype is to communicate the general aspects of your proposed solution, whether those are the works-like aspect or the looks-like aspects. The prototype can take the form of a series of storyboards if the project solution is a process, or it can be a physical model if the project is a physical one. Refinement, obviously, is not necessary in the rough prototype. It can be constructed of those basic materials we talked about before, and it can include hand sketches. And again, the purpose of your rough prototype will be both that internal processing piece as well as collecting stakeholder feedback. Your refined prototype will be a more polished model of your proposed final project solution. The most important aspect of your refined prototype is that it will be, well, refined. It will have more detail. It will be accurate enough to convey the most important features of your proposed project solution. And it can be presented to the client so that they can provide feedback about your proposed solution. The prototype should be finished with details such as printed rather than hand-sketched graphics. Details like color that accurately help show the details of your solution. And the purpose of your refined prototype will be, again, internal processing, but also communicating what your final design is. You may have heard that I mentioned 3D printing. A word about 3D printing. Sometimes 3D printing is a good idea for your refined prototype, and sometimes it is not. We'll cover good uses and bad uses of 3D printing. Good uses are for complicated geometry, which would be hard otherwise to make in cardboard or wood. It's also good when you already have a 3D model of your design rather than you'll need to create one first for your 3D printed model. It's another good use is where you need to control wall thickness. 3D printing is really good, again, for complicated geometry where you can control a lot of different aspects. But this is where it's a bad idea. Simple geometry. If you need a box, go to Radio Shack and buy a project box. It'll be a lot faster to build a box by hand out of cardboard or foam core than it will to be building a 3D model, transferring it over to the design garage, and waiting for your printout. It's also not ideal where flexibility is needed, such as in a living hinge. Another bad application of 3D printing is when you are in a rush. 3D printing is not a speedy process. The limitations of 3D printing are, as I mentioned, it can be very slow. It can take overnight, and success rate can be as low as 50%. Other limitations include overhangs. Those can be tricky in a 3D model. The 3D print also has a low resolution. Surface finishes can be quite rough. The part can be brittle. It's full of fracture lines. The part requires a solid base to serve as a platform for printing on. If it's a circle or a sphere, that's not enough of a base to print from. It requires an STL format, or a file that can be converted to STL. Another limitation of 3D printing is that there's only a limited number housed in the design garage up the hill. Of course, you can go outside of mines to get it done, but that will also still have some of the same limitations here. So a few words about where. We have the EPICS workshop. It's downstairs in our engineering annex building. It's good for low accuracy prototype making. Our shop schedule will be posted on our epics.mines.edu website shortly. Other resources on campus include the CECS Design Garage up in Brown Building. This is a more of a higher accuracy prototype making shop, less dust, more plastic. It includes the 3D printers. It also includes a laser engraver, a vacuum former, and other materials. Check out their website on the CECS Mines page to learn more about what's in their design garage. The process to access the design garage would be to go visit and understand whether there's a backlog or not. Introduce yourself to some of the assistants in there and figure out what they need to help you with your part. And again, make sure you give plenty of days ahead of when you need the part to get all the bugs worked out. And the last 4 weeks of any semester will be very, very tight. There's no guarantees. You must have a backup plan if you're going to be using this for your final prototype. Another resource on campus is Arthur Lake's Library. They will soon be lending tools out. If you're interested about what tools they'll be lending out, please inquire at their front desk.